All right, so this modular, this normal distribution, so we talked about the normal curve and the z-scores. You have the z-scores, how many standard deviations you are away from the mean, right? So the z is in the, or zero's in the middle because the mean's in the middle, so you're 0 away. And we talked about if you go 1 standard deviation away, it's 68%, 2 standard deviation away, it's 95%, 3 standard deviation away, it's 99.7%, right? So that's the empirical rule. So these z-scores right here, well, we kind of talked about what happens if it's 1, 2, 3, or -1, -2, -3. But what happens, or how do we find what percentages is underneath the curve if it's like 1.26%, okay? Like we kind of talked about 1, 2, and 3, the whole numbers there are the integers because it's -1, -2, -3. But what happens if you have the actual percentage are different numbers here that are harder to work with, okay? So we'll come back and I'll show you how to do this in the calculator real quick. But what I think really helps is drawing these out, okay? So let's draw. Can I fit 3 of those on here? Let's see. Did I draw it too big? Too big. One, 2. Oh, almost. Close enough, right? Okay, so we have 3 different problems that they give us here. That's why I'm drawing 3 of them, but it's basically the 3 scenarios that you see on these. The first one is that P of Z is less than or equal to 1.2. That kind of looks like the button on the calculator, which we did use in the last module. But what you're doing here is you are saying, okay, Z of 1.26, you know zero's in the middle. That's when Z equals 0 right here. So 1.26 is going to be somewhere over here. Like 1.26 is positive, so it's going to be on the right side. That's 1.26. And then what I want to do is find anything over here. Okay? I'm trying to figure out, there's a couple different wordings that they use. They say this is what I'm actually doing is finding the area under the curve, but I could be finding the probability that we randomly pick someone and they are less than that. They're in that blue area. What's the proportion that is less than 1.26? All those different words would work. So actually into the calculator on this one, super easy because all we do is use that button in the calculator and do 1.26. Boom, that's it. That's our answer. That's easy, right? All right, so what happens if it's, we kind of talked about this, but if you have greater than, oh wait, let's talk about this real quick. So what our answer here is that this is 89, that area under the curve is 89.6%, okay? Or 0.896. Like the probability that I randomly pick someone and they fall under in that blue area is 89.6%, okay? On this one, again, same idea. You can think about Z equals 0 being in the middle. I want 2.06. That would be over here. And this time I want greater than. So I want the area over here. So it's going to be a very, very small amount, right? Okay. In the calculator, I cannot flip. Oops. I cannot flip the sign. All I can do in the calculator is find less than or equal to 2.06. So, but in the calculator, wouldn't this be the same thing as finding everything to the left? Okay, so if that was 98%, then I know that this has to be 2%, right? If this was 98%, then this little guy right here has to be 2%. So to do this, to flip the sign, to make it be greater than instead of less than or equal to, just like binomial, we do 1 minus, okay? So if you ever need to find the right side or the greater than, you have to flip the sign and do 1 minus. And this accounts for 0.02. All right, and then the next one is a little bit trickier. We're going to have to use our brains here for a second and think. I know sometimes that hurts, but for this one, all right, so again, we have the Z equals 0 in the middle. We're trying to find negative 0.71 and 2.15. So I'm trying to find everything in the middle of this right here, right? But I only have the one button in the calculator, which is the less than, right? Oops. See if I know this is super small, but just bear with me for a second. If I could find 0.71 or negative 0.71 and it would be to the left right here. It would be over here, right? To the left. Oh, wait, let's switch that. Sorry, let's do the 2.15 first. 2.15. If I could find the 2.51 to the left into the calculator, okay, all I would do in the calculator is I'd do p to the z of less than or equal to 2.15, right? That would find everything to the left. What if I found negative 0.71 and I found everything to the left there? Okay. What if I took away this area right here from this right here? Doesn't that leave me with what's in the middle? Do you see that? Can y'all see that at all? Is it big enough to see? So if I took this little left tail away from my one on the left, that would leave me with what's in the middle. So what I have to do here is subtract the bigger one from the smaller one, and that will find my answer. Okay. We don't use that concept a lot. I believe that's the only one we use on this one. The biggest one, we're going to use that middle one where if you got to flip the sign, you got to do 1 minus, but we've talked about that a lot too. So on the in-between one, what you do is you do the bigger one minus the smaller one. And just to make sure, I'll show you on the calculator real quick. So like the first one, we're just using this button, and we do 1.26. Boom, we get our answer, okay? Next one, we have to do 1 minus to flip the sign, 2.06. Okay. Man, I keep hitting 0, but I don't. Okay, 2.06. 1 minus the p to the z. So 2.06 finds to the left. That gives us 98%. Do 1 minus 0.98, then gives us our 0.002, or 0.02. And then the other one, we do the bigger number first minus the smaller one. So that picture I drew is drawing the normal distribution. I think that's really useful to draw that picture out and just shade it real quick if you're doing it. So I will do that a lot as we're doing that. But all you got to do is draw the bell shape out real quick and draw it and do it right there. So it makes it real easy to do. All right, so this topic is a little strange, but there's one I got to do. I know there's a weird one. You are taking the normal curve and you are shading it onto like the standard normal curve. So what the standard normal curve is where you have the z-scores, the 0, 1, 2, 3, and -1, -2, -3. So on this one, like my mean is -3. So if you see the mean where it starts, the middle of this one is right here at -3, okay? So what you have to do on this one is find your z-score before you do anything. So it's just kind of plotting, when you have a different mean, plotting that onto the z-score chart. So your z-score formula, remember, is x minus the mean divided by the standard deviation. So to do this, I would do my x here is less than -2, okay? I'm not doing less than, I'm just figuring out the -2 part first. So -2 minus my mean divided by my standard deviation would be 1/2 or 0.5, okay? So we want to find what the probability of z is less than 0.5. You actually, do you have to find it on this one? No, I think you just shade it. Yeah, you just shade it. So you don't even have to find it, but that is what we're finding. I'll erase that so you don't get confused. But we do want less than z of 0.5, okay? So we would come over here, we would put a line at 0.5, and then we would shade to the left. And that's all you have to do. So this is just showing you that we can take any mean, any standard deviation, plot it on the graph, and it would be, though those are the same chart. Those mean the same thing. Even though one's at -3 and one's at 0, we've just standardized the data there. There is one more of these that I know I want to do. Let me try to find it real quick. This one right here popped up quick. This one confuses people because it says between 0 and 4. Well, what that means is you're going to have to find 2 z-scores. Okay? So the between, my goodness, that was big. Between 0 and 4. So you have to find, for x equals 0, you do 0 minus -2 divided by 4 would be 0.5. And then you have to find the 4. So for my z-score for that, I would do 4 minus negative 2 divided by 4. What's that? 6 over 4 or 1.5. Okay. So you have to find it for both of those. You have to find the z-score for both of them. And then I come over here and say, okay, I'm doing between 0.5 and 1.5. So I go to 0.5 and I go to 1.5, and then I'm going to shade between those. So you actually have to plot it on both of them. Okay, so you got to find the z-score for both of those when you do that. So this is, all right, how you do that to find those, you find the z-score, you can plot it, you can do those different things. Now we got to put everything that we've done together so far, basically. Oops. So now we get into like real life problems and where this is used. I'm not doing that one first. I'll try to come back to that one. Give me... Sorry, I was trying to think of how I wanted to... Okay, we'll just do it in the calculator. I'll do it in the calculator, then I'll write it out so you can see. But suppose that the height of adult men in the United States are normally distributed with a mean of 70.5 and a standard deviation of 2.5. So there's my mean and standard deviation. And it's going to say something like this. What proportion, or what's the probability that we find, or something like that. What is the proportion of the adult men in the United States who are at most 6 feet tall, which is 72 inches? So that is my x, okay? So the first thing we want to do is find our z-score. So we can do it inside the calculator like this. It is the x minus the mean divided by the standard deviation. So if you didn't see what I did there, by the way, I hit the z button, I hit the division sign to go ahead and make a numerator and a denominator, and now I start plugging it in. 72 minus 70.5 divided by 2.5. Okay. Almost every problem is going to start with that right there. Then you got to figure out, do I need to do the 1 minus or not? So this one says at most 72 inches, which is less than or equal to. So I should just be able to put that in there and get the correct answer. That should be the correct answer for that one. Okay? So we are doing everything the same that we've done. We're just kind of have to find the z-score as we're doing it, but you can do it in the calculator all in one swoop. I mean, technically, you're welcome to do it on the side and do 72 minus 70.5 divided by 2.5. What is that, like 60? 1.5. 1.5 divided by 2.5. Yeah, it was 60. So then you could put that into the calculator and do it like that. You're welcome to do it like that too. I just do it all at once because why not? We have a calculator that does that for us, okay? Now, what you have to decide, the big decision you are making is, okay, if I have 70.5 in the middle, my x is 72. At most, 6 feet would be less than or equal to 72. At most is less than or equal to. At least is greater than or equal to. So at most, I am shading to the left, okay? This is what I mean by it does not hurt to make a quick sketch. And just to make sure in your mind, okay, I'm shading to the left, so I just use less than or equal to. If I shade to the right, I got to do the 1 minus. That's just a quick sketch, and that's what I mean by those, all right? Is basically what those topics is, and if you can do that, you'll be just fine on the next 2 sections, basically. On this one, let's do another one. So, again, we'll walk through it on the calculator. Oh, no. I just like that screenshot of the picture on the calculator. So we'll walk through it on the calculator first. So suppose that the time required to complete a 1040R tax form is normally distributed with a mean of 110 and a standard deviation of 10. What proportion is completed in more than 89 minutes? All right, so 89 is my x. First one, I'm going to make a fraction. 89 is my x minus the mean divided by the standard deviation. All right. That's kind of doing, I've got to find my z-score inside the calculator like that, right? But it says more than 89 minutes. So now I think, okay, now it says more than 89 minutes, so I need to do 1 minus, right? And that should check my answer there. That should make it. That is the easiest way to do that one. Again, what I would do, just real quick on your paper, okay, 110. Like I remember doing this just to make sure I always shaded the right way and did the right thing. 110, 89. 89 would be on this side. More than, I'm going to shade this way, okay? So that tells me since I'm shading to the right, I have to do 1 minus that number, okay? That's how you do that. That's how you make sure you get those right. So more than X. So this would be X is greater than 89. There's your mean. There's your standard deviation. That is what you want to do. And, of course, you're using this button on the calculator. Making sense? It's just kind of putting all those pieces together. We will continue to do this a bunch. There was one more at least. So that's greater than or equal to at most, less than or equal to at least. That very first one that I started with, at most, less than or equal to, at most, less than or equal to, at most, 84. This one, I guess I can put it in the calculator. Suppose that the annual rate return of a common biotech stock is normally distributed with a mean of 7% and a standard deviation of 6%. Find the probability that the 1 year return of the stock will be negative. That's kind of confusing because it just says will be negative. What you want to do on this one is put in a 0 for your X because anything less than 0 would be negative. Does that make sense? Anything less than 0 would be negative. Okay? And that gives me the right answer there. So we use 0 for the negative. That's just a weird math thing, and they'll do this a couple times on a couple different topics. And they'll say, okay, positive is greater than 0 and negative is less than 0. So when we see the stock will be negative, that tells us X has to be less than 0. Okay, so our X is equal to 0, our mean is equal to 7, and our standard deviation is equal to 6. But it's less than, so we are shading to the left here. All right, the next topic. So on these right here, and this is probably hard when you get to the test a little bit, but on these right here, you are trying to find the proportion or the probability that you randomly pick someone and it falls in there. They always say proportion, I think, on Alex, but you can do probability as well. The next topic says, what if we are trying to figure, they give us the proportion and we're trying to work backwards, okay? So suppose that the height of adult women in the United States are normally distributed with a mean of 63.5 and a standard deviation 2.5. Carmen is taller than 90% of the population of the U.S., okay? So your doctor tells you you're in the 90th percentile, but doesn't tell you how tall you are. This is how you'd find it. Taller than 90%. All right, so what I'm going to do, and this is the way Alex has it set up, which is nice, the button right above the one we were just using. So you have this one that gives you the proportion. This one, they give you the percentage and you're trying to find the real number, okay? This button always finds to the right. All of these buttons find to the right, okay? So we're using this button right here. Oh, no, it won't highlight for some reason, but we're using this button right here. All these buttons find to the right. And if you look, almost all the buttons do find to the right. So greater than, greater than, greater than. These all find to the right. It is very unusual for one to find to the left. It just happens to be the two we've talked about so far go to the left. We use these two buttons as well, or these 4 buttons as well. So it's the same idea on something that goes to the right. Is if I want to flip the sign, I do 1 minus. But on this one, I already have the answer in here, so I should have asked you real quick. But if she's taller than 90% of them, that'd be 90% to the left. So then what percent is to the right? 10%, right? So we are going to do Z of 10%. What's that number? 1.28. 1.2816, I guess, because it says to round. Okay, so this is 1.2816. This button right here gives you to the right, right? So if we go back to our picture, what we have in this problem is 90%. 90% is taller, or she's taller than 90%. So that's 90% here. So what we are really looking for is what is the z-score that goes along with this being 90%, okay? Since it gives us to the right, what we are going to do is figure out this area. We are going to do z to the 0.10. Okay, that makes sense? So it's kind of like subtracting 1, but you just subtract 1 first before you put the answer in. You always do that. It'll always work out like that. All right. So now we have that number. A little bit of algebra. I don't do very much algebra in this class, but this is the easiest way to do this problem. And you can write this down. We've seen the z-score formula forever, right? Well, this time I have the z-score. My z-score is this right here. I have the mean and I have the standard deviation, so I'm missing my x, okay? Does anybody know how to solve for x in this equation, this z-score equation? Breaking out your college algebra skills, but we don't do algebra, so we'll write this equation down, and then you don't have to worry about it. Anybody? When you have a fraction, you don't like fractions, so you get rid of it. I'm going to multiply both sides by the standard deviation, okay? So the standard deviation cancels out, and I have the standard deviation times z equals x by minus m. To get the x completely by itself, I add the mean, okay? So when you're trying to solve for x, you do the mean plus the standard deviation times your z-score. So if you want to write down this formula, we'll see if we need it on the test or whatever. But my point of doing that is just to show you this is not a new formula. This is just the z-score formula rearranged, okay? So what we do here is we're trying to find x. So our mean was 63.5 plus my standard deviation is 2.4. And then we did have to use our z-score number over here, 1.2816. And I didn't put the answer. I didn't click solve to have the answer, so I actually got to work this one out. 2.4 times 1.2816 plus 63.5 is 66.5. Round your answer to one decimal place, actually. So 66.6. Okay. So you have to use the calculator to find the z-score that goes along with that percentage, and then you have to plug it in. Let's do one more of those. I know we're spending most of the time on this section, but the next section goes pretty fast, I think. If we need to do half of it next week, that's fine. What does this one mean? Okay, so I won't read all this. But the mean is 50, the standard deviation is 15. The customers with a score in the bottom 5%, okay? So the bottom 5%, remember this gives you to the right, so the bottom 5% would be to the left. So what number do I want to put in here? 95, 0.95, negative 1.6449. Negative 1.6449. That is my z-score, okay? So now we are using the formula mean plus the standard deviation times the z-score. So my mean was 50 plus my standard deviation, 15, times my z-score is negative 1.6449. I forgot to click solve again, so let me get my calculator. 15 times 1.6449 negative. This would be x equals 25.3, and that would be my answer. Again, it never hurts to draw it out real quick and say, okay, bottom 5%, bottom 5%. That would be like down here. That's my bottom 5%. Okay. So with my calculator, I'm trying to figure out what this z-score is. My calculator is going to give me to here, so this would be 0.95. Okay. And this question mark, the answer is negative 1.6449. I know this is a lot to ask because we just started doing normal distribution this week, but the idea here also is that you pay attention to the number that you're getting. Let me see if I can make this bigger so I can reach it up there. But you also pay attention to the number that you're getting, and you're starting to learn the normal curve as you're doing this. And you can say, okay, I'm at the bottom 5%. That's where I am right here. That's the zero's in the middle, so I should have a negative number when I'm on the left side of this graph, right? If I'm over here on the left side, I should have a negative number. And that's the way you can kind of check your answer to make sure you're doing it right. And then you also know if my z-score is negative, I am lower than the average. My whatever I'm talking about is going to be lower than the average. It's probably what we should spend more time on. All right. We'll jump into the next section. I don't know if we'll finish it or not, but